Okay, so last question was about a trampoline. We were all jumping for joy, as this lady appears to be. So Chantal is bouncing on the trampoline. When her arms and legs are stretched out, her rotational inertia is 4 kilograms per metre squared. And she's got a mass of 56 kgs. So part A says when her body is stretched out, her rotational inertia is approximately a third mr squared. Calculate her effective radius. So this is just a case of putting numbers in. It's only an achieved question here. So we're told her rotational inertia in the question is 4, and we're told her mass is 56 kgs. So we just need to rearrange that to find r, and we should get 46 centimetres, 0.46 metres. Now, like I said, that's just an achieved question because all you're doing is putting numbers into an equation. So while her arms and legs are stretched out, her angular speed is 9.82 radians per second. She does a complete rotation in this position. Show that her angular momentum while she's rotating the stretched out position is 39.3. So this is just a show question. So again, it's just going to be an achieved question. There's nothing particularly tricky about this. So angular momentum is IW. So we're told that her rotational inertia was 4, and we're told that her angular speed is 9.82. You put that in, hopefully we get 39.3 because it's what it's asked us to show. So yeah, just an achieved question for that one. Part C then says calculate the time it takes us to rotate once in the stretched out position. So now we need something that's going to link our rotational, our angular speed to time, and we have this link between time and rotational speed. It tells us that she does 1 rotation, so we know that the angle she turns through is going to be 2 pi, and we know her angular speed. So that gives us a time of 0.64 seconds. Again, only an achieved question, but a fairly straightforward one at this stage. And then the only excellence opportunity in this question was the last bit. Explain what she must do to her body if she wants to make as many rotations as possible in the air. So we've looked at this when we looked at examples with people diving. We looked at it when we put you guys on the chair and spun you around. So what she wants to do is minimize her rotational inertia. So she wants to minimize her rotational inertia. So what she wants to do is pull her arms and legs in. Because that will help to minimize her rotational inertia. So when she's minimized her rotational inertia, the other thing that we need to remember is that angular momentum is going to be conserved. Okay. So if angular momentum is conserved, remembering that angular momentum is given to us by IW, if we are going to minimize her rotational inertia, so if this comes down, this is going to stay constant because it's conserved, then this must go up. So because of that, a smaller rotational inertia, smaller I, gives a larger rotational speed. So she's going to have a larger angular speed here. that's going to lead to more rotations. In the same time. Okay, so if you just got as far as saying remembering that she needs to pull her arms and legs in, tuck herself in close to her body, that got you achieved. If you mention that that minimises rotational inertia, that kind of got you up towards the merit level. You really wanted to say that angular momentum was conserved, because that's really the key to this equation working, is that angular momentum is conserved. And then to get up to the excellence level, if you got the angular momentum was conserved, therefore larger speed, more rotations in the same amount of time, it got you up to the excellence level. So again, I think when you think about it, if we just go through it in stages, that again, that's a fairly straightforward excellence question. So overall on this paper, you needed to get 10 achieves to get achieved, 8 merits and 6 achieves to get merit, and 5 merits and 4 excellences to get excellence overall. But hopefully now you've seen how you go through each of those questions. You're probably thinking that was a lot easier than you thought it was, hopefully.